changes are vulnerable to power system. A sudden changes means a sudden drop in load or sudden increase in load may affect the power systems. That is that you have to keep in mind. So general power system equipments. So the generators, power transformers, capacitors, inductors, bus bars, feeders, circuit breakers, isolators. So these are the devices which should be monitored, controlled, and mainly protected from overcurrents or short circuit or whatever faults, packet faults, or too many other issues, power quality issues will be there. So we have to protect all these equipments with the following SCADA devices. These are the components of included in SCADA, like control and protection relays. So instrumentation transformers are CTs and VTs. Sensors and instrumentation meters. So sorry, intelligent meters. So it can give even the voltage, current, frequency. So what are all the main parameters of electricity, it can record and it can provide you the details. So then the fault recorders, different types of fault recorders available, like digital fault recorders, like sorry. Okay, then the DC supplies, which is the batteries, so which is the main thing. So which is supplying this control and protection relays and also used as a backup. Hello, hello,
Yes or
hello,
no?
hello.
Yeah, கேக்குதா?
Sir.
Yes.
ப்ரொசீட் பண்ணு.
Okay. So the next is the substation automation system. So here, just see the legend. So these are the main terms used in the substation automation. One is the main thing is a distribution management system. Hello, 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 sir. So these are all our software modules. So the main thing is the power factor, frequency, kilowatt, current, voltage. These are the basic parameters. So which will be plotted against time. So from that plots, we can get various results. So we can get the various analysis through SCADA. So this is a synchronophaser technology. So it is a technology to identify grid disturbances. So here, see the around four generators are connected through the connected in a grid. So if you see the grid G, grid E, so it's a bus bar, okay, bus bar E. So here the phase angle is 0. Phase angle is the angle between the voltage and the current. So if it is 0, the power factor is unity. Okay, it is closely to unity. So we can keep the reference of this phase angle, and which can be compared to other buses, like here it is leading, so in A it is lagging. So while keeping the phase angle at E at reference, so you can and there will be a GPS device will be there, so you can time tag the phase angle. So at the time, you can refer the other phase angles, and you can see. So here it is too much lagging. So here it is too much leading. So in any of these can be go faulty, or maybe it will fully go out of the grid. This is the synchronophasor technology. So with a reference phase angle, which has a better power factor, you can predict the disturbances within the grid. So these are terms. So phasor measurement unit. There are sensors at the substations which can measure the phase angles. So it is otherwise called as wide area monitoring system. So it is like a complement to the SCADA. It is not a regular SCADA. So it is one of the method to identify grid disturbances. So once we identify, so you have to correct the power factor. So here the capacitor banks are connected across the shunt capacitors are connected across the power system. So here from the power system, from the CT and VT, current and voltage can be go through the go to the PLC. So there is a so from the voltage and current you can get the power factor. So then master station will be here. So it will go to the RTU and master. So here auto and SCADA switch will be there. So what is the switches for means? It's like when SCADA goes offline, so it will work as a independent system. So it will not go. There is no connection between master. It will work automatically without the master. And this switch position is for the capacitors. So whenever power factor is lagging, so you have to switch on most of the capacitors. So when it is leading, so the vice versa, like that, the switch position can be altered. So this is the control over the power factor through SCADA. So the next one is how is SCADA evolved? So initially, before the electricity, there is only a mechanical thing, and the labor force will be there. So which gives in the terms industry. So industry then supplied with electricity. So automation is introduced. So then automation plus computers, the SCADA will be introduced. From the SCADA, now it is connected over the network. So which will lead to IoT, like Internet of Things or the smart systems. So in our electrical system, it is like a smart grid system is evolving. So this is how the SCADA is evolved, and still it's evolving day by day with a greater extent of information and reliability. So then we'll go to the smart grid. So this is a regular grid. So a grid is in the sense from the generation